Okay, in the previous video we talked about intervals and we defined them. And before we go to unions and intersections of intervals, let's remind ourselves what intersection and union represent. So in this example, and again, it may be a while since you've seen these unions and intersections, so I'm going to review first, then we'll go through and do the definitions. Let's just see what you remember. If we have a set V, which is the letters, little lowercase letters A through G, and we've got W, which looks like it's the vowels A, E, I, O, and U. Let's find the intersection and the union of oops, this should say V intersect W and V union W, because those are the names of our two sets. V intersection W. Let's do that one first. Well, what is V intersection W? It's another set, but it's the set that contains the elements that are in both of these sets. I think of it as the overlap. So A and E, the only two vowels over here. A and E. That's the intersection. An intersection typically makes it a smaller set. The union makes it a bigger set usually. So V union W, it's another set, so we need the squiggly brackets. It needs to include all of these letters and all of these letters as well. What we're doing is we're going to write down every letter that's either in this set or in this set. So I'm going to write down A, B, C, D, E, F, G. That's all those. And then what am I missing? I've got A already. I've got E already. So I need I, O, U. So hopefully you remember that, but just in case you don't, we're gonna go over the definition here. Intersections and unions of sets. Suppose A and B are sets. They could be intervals, because an interval is a set of real numbers. A intersection B uses this symbol. It actually looks like the upside down version of the union. A intersect B, it's a set of elements that are in both A and B. So it's got to be in both A and B. Another way of saying it is A intersect B is the set of all x's, which are real numbers, set of all x's, such that x is in A and x is in B. And now we move on to union. A union B is a set of all elements that are either, I'll say in either A or B. And in parentheses, I'm going to go ahead and write or both, but that's kind of optional. But it does mean all the elements in either one or both. But if you're in both of them, you're in one of them. So let's see. That is, A union B is equal to the set of all x such that x is in A or x is in B. You could think of that as either or. It only has to be in one of them. But if it's in both of them, it is in at least one of them, so it would be in the union. So one way of coming up with a union, if it's a union of two sets, like up here, just take all of these elements, write them down, take all of these elements, write them down, but don't write them down twice. If it's, for example, A is in both, I didn't write down A twice. In a set, you never repeat the same element. All right, so let's get to the part that's a little tougher. We're going to take our sets A and B as being intervals. So, if A is this interval, all of the real numbers on the real line, obviously, from -1 to 2, including -1 but not 2. And B is everything from 0 to 4, not including 4, but 0, but it does include 4. Let's find the intersections and the unions. Well, one thing we could do is I'm going to graph on the real line this interval and this interval. So A, let me put B down here first. So 0 would be here. 1, 2, I got to go to -1, so I need -1, 0, 1, 2, 3, 4. I need to keep them lined up here. Okay, so negative 1, 0, 1, 2, 3, 4. Negative 1, 0, 1, 2, 3, 4. So A goes from negative 1 all the way up to 2, but not including 2, so I have an open circle on 2, and shade everything in between them. B goes from 0, not including 0, so an open circle, up to 4, including 4. Okay, so we've shaded them both, and remember now what the intersection is. Negative 1, 0, 1, 2, 3, 4. The intersection is the numbers that are in both sets. Okay, so for example, the numbers 3 and 4, they're in this set, but they're not in this set, so it's not in the intersection. So what we do basically is I draw a line like this. Between those two lines, all of the numbers are in both sets. So the intersection is going to go from 0 to 2. Now the question is, do I put open circles or closed circles? Well, 0 is in this set, but 0 is not in this set, so it is not in the intersection. So from 0, and the number 2 is in this set, but it's not in this set. It has to be in both of the sets to be in the intersection, so it's only going to be everything in between 0, 1, 0, and 2. That's the intersection. So, just as a pictorial example again, if this is an interval on the real line and this is another interval on the real line, and if they overlap like this, then the intersection of these two intervals would be from here to here, where they overlap. Okay, now the union is different. The union is any number that's in either one of the two sets. So, negative 1 is in this set, so it's part of the union. All these numbers are part of the union. All of these numbers are part of the union. So what numbers does that include? Everything from negative 1 all the way to 4, including negative 1 and 4. So negative 1 gets a filled-in circle, 4 gets a filled-in circle, and then shade everything in between. Okay, there are before we move on to more examples, I'd like to create one other example here. Let's say we had this is a bonus example. Let's say we had A equals the interval 0 to 1 and B is equal to the interval from 2 to 3. Notice the difference between this example and the previous two, our previous example here, is that these intervals don't overlap, do they? They would meet, they would not overlap at all. They'd be separate. So what is the intersection? What is the overlap? It doesn't exist, does it? So in this case, we would have A intersect B is the empty set. There's no element that's in both of these sets. Notice all of these elements are less than 1, and these are all greater than 2. So nothing in between 1 and 2. So there's like a gap between them. So the intersection is the empty set. The union is, well, here's how we would write it. A union B is just going to be 0 to 1, union 2 to 3. Just union them together. There's nothing you can do. When you got separate intervals, you put a union in between them. Okay, we'll see examples of these again. All right, number 6, we have, I'll see if I can leave this on the screen. this example. Okay, the first question is, notice the intervals are the same two intervals. Here we're taking the intersection, here we're taking the union. Do these two overlap? This one goes from -3 up to 5.5. This one goes -1 up to 10. So clearly they do overlap. Maybe I'll draw one number line. If 10 is here and -3 is down there, -1 is there, 5.5 say, hopefully that's pretty close. What we've got, this first interval, is from -3 to 5.5. Everything in between them. Now to find out where it overlaps with the next one goes from 10, well, it goes from -1 with an open circle. I'm writing one above the other so it's clear what's going on here. This is -1 to 10. What's the overlap? The intersection is from -1 to 5.5, not including the endpoints. So the intersection is -1 to 5.5. That's the intersection. That's the answer to this. Well, the union, maybe I'll put this down here to remind us, that's the intersection. The union, basically you just have to go, since they overlap like they do here, just go from the leftmost point to the rightmost point and we're done. -3 with a filled in circle, which means it'll be a square bracket, all the way up to 10 with an open circle. So this will be -3, comma 10, like that and that. This is the union. And once you do a couple of these problems, you don't even have to graph them anymore. All right, let's do one more pair for the intersection and the union. We got two open intervals. We got parentheses all the way around. Do these overlap? 9 to 13 is one of them, and 10 to 11.5 is. This is a special case to deal with. Do they overlap? Of course they do. But what's different about this one and the previous examples that we've done? Maybe this is worth graphing. I was thinking I wasn't, but I'm going to graph this. Let's use this. Okay, so I need to make sure I have a 9, 10, 11, 12, I probably don't need 13, but 10, 11, 12, 13, 14. All right, let's graph 9 to 13 with open circle and shade everything in between. That is the first interval. The second interval goes from 10 to 11.5 with open circles. So 11.5 is right between 11 and 12. 10 is 10. And so I'm shading this again right above the other one. I don't want to put them right on top of each other. So what do we know about where these two intervals intersect? It turns out that they overlap from 10 to 11.5. Exactly this. This whole interval is the intersection. So 10 to 11.5, that is the intersection. That is the overlap. It's the only numbers, the numbers strictly in between 10 and 11.5 are the only numbers that are on both of these two intervals. And how about the union? Well, it's all the numbers that are either in this one or in this one. Well, notice, if you're in this one, you're also in this one. If you're the number 11, well, 11 is in both of them. So the union is just going to be this interval, the one from 9 to 13. I'll say that is the union. So this one was kind of a special case. And why was it a special case? Because one of them is a subset of the other. The second one is completely contained inside of the first one. We could write, using the subset notation, we could write 10 to 11.5. All of the numbers in between 10 and 11.5 are subsets of 9 to 13. Every number in here is also in here. I don't think we've looked at this subset symbol yet, but for later.